Previously, we looked at how to train your model. Now that the training process is complete, let's move on to the next aspect of the machine learning pipeline, that is evaluation. As part of the evaluation step, we want to understand how your model has learned and if the results being produced are of acceptable quality. In order to do that, first we're going to look at how the generator and critique losses have changed during training. Then we're going to look at certain musical metrics and see how that changed during training. Finally, we're going to hear some samples that is produced by the model and judge how they sound. First, let's start by loading the model checkpoint that was saved during training. Okay, so loading the model checkpoint is now complete, and let's plot the losses. Cool. If you remember, we had set the number of iterations during the training process to 1000. So we see that the training is complete, and both the critic and the generator losses begin to converge after 300th iteration, and by the 1000th iteration you see that they're almost flat. This is a great cue that the model has converged and completed to train. The next thing we want to look at is some of the musical attributes of the samples that are generated by a model. While losses like generator loss and critic loss are a great cue to understand what's happening, understanding some of the underlying musical properties of your generated sample and seeing if that relates well to the statistical average of your training dataset is another way to see if your model is producing songs that is similar to your training dataset. Going back on the cell, some of the musical properties we want to look at are empty bar rate, pitch histogram distance, and in-scale ratio. These are all various musical attributes and we don't have to get into the depths of it, but the idea here is the qualitative property of the samples being generated from a musical perspective should resemble the training dataset. Now let's see if that hypothesis is true. Okay, we have the metrics for the three different musical properties we were talking about, which is empty bar rate, pitch histogram distance, and in-scale ratio. And we have them plotted for each of the 4 instruments or tracks in the output music. The red lines that you see in each of these plots is the expected value, which is a statistical average of these properties for all the songs in the training dataset. The blue scatter plot that you see is the statistical average of all the samples that were generated for every iteration. Initially, notice that when the iteration number is low, the gap between the statistical average of the generated samples versus the expected value is large. However, as the training progresses, the blue scatter plot kind of converges with the red expected line. This is a great cue that with time, the quality of music produced and the musical attributes are getting closer and closer to the training dataset, which is exactly what we want. This is another cue that the training proceeded as expected.